Okay, so I have a problem here that it comes off of the quiz, the homework, and possibly the review homework, and it's dealing with the real zeros on a fourth degree polynomial. I've already got the work shown for you, so let me just show how I went about approaching this problem. Remember that when we have a polynomial and we're looking for the roots, here is our fourth degree polynomial. And in order to make the list of roots, we have to find what are the factors of p, which is 40. So I list all of the factors of 40 along with all of the factors of q, and I left one of the factors off. But anyway, and then p divided by q is the list of all the possible roots for this particular polynomial. The next thing I'm going to do, because I have a list of numbers I'm going to be using in my table, I'm going to go ahead and I'm going to put this polynomial into my graphing calculator, and I'm going to graph it because I kind of want to see what this thing looks like. Here on the left-hand side is the picture of the polynomial we're talking about. And I had to play around with my window, so I changed the scale on both the x and the y values so that I could really clearly see some of the curves that were going on here. And why do I want to do that? Well, when I'm dealing with a polynomial of like definitely a fourth degree or higher, on a fourth degree polynomial, I have roots that could potentially be repeated roots. Remember that when we have a root and it comes down and it touches at that spot and it bounces back off, this point right here would be the root, but the multiplicity of that root would be even. So when I have like a fourth degree polynomial like this, I don't know at this root if we have a repeated root or what. So when I want to eventually make use the table of values, I kind of want to have an idea of what's happening for the real roots of this function. And I can clearly see by looking at the picture here that I have 4 distinct places where we are going to be crossing the x-axis, meaning I'm not going to have any repeated roots, or I'm not going to be using one of my roots more than once. That's the purpose of me looking at a picture like this. Once I kind of have a vague idea of what kind of roots I would be possibly looking for, or how many roots maybe I'm looking for. And by the way, one other thing, since I can clearly see all 4 roots here, then I know that this function also doesn't have any imaginary roots. So maybe that's important for me as well. So what I do is I go over here to the table of values, and remember we had our list of possible roots up here, and I'm going to plug in just the first one. So I plug in the number 1 and I find out that it is a root. Now another thing I'm going to do while I'm here at the table is, because this is a fourth degree polynomial, I'm going to have to do synthetic division on it more than one time to get it whittled down into a quadratic or an x squared function that I can then factor. Because x to the fourth, which is my fourth degree, divided by this factor right here gives me x cubed. Now I can't factor an x cubed using factoring or the quadratic formula, so again I would divide by the second root, and that's going to end up giving me an x squared. So that's why I've got one root, and while I'm at the table I'm going to just go down my list and plug in the roots until I find the second root. So these are the 2 roots I'm going to use synthetic division on. Now down here, make this a little bit smaller, down here you can see that I have the synthetic division. The first row right here, these are the coefficients of the original polynomial that we started with. This is my x to the 4th polynomial. This number 1 is the first root that I found off the table. When I do the synthetic division, the coefficients down here that I get from doing the results of the synthetic division is going to be my x cubed function. So these are the coefficients of an x cubed function that is reduced off of this x to the 4th. So because I cannot factor this polynomial, I use that second root from the table, do synthetic division on this new x cubed, or not new, but I do synthetic division on the x cubed function that I found. And finally, that leaves me with this down here. So I've done synthetic division twice on two separate roots, giving me an x squared function. Okay, so at this point, once I know that, well, I can either use factoring to find the roots of this, or I can use the quadratic formula, I'm going to come down here, and I like to kind of rewrite what it is that I just found from above. So I started out using 1 as a factor, so here it is in its factored form, x minus 1. The next root I used was x plus 2 in its factored form, and this is the quadratic equation, which is the result of the synthetic division that I did above. So I'm going to just use trial and error on this quadratic equation, and when I do that, that's where I broke it up right here. Now remember that when I use trial and error on this, I'm going to break it up into its two binomials. So I have 1 and 2 binomials right here. And I know that the second sign is negative, so I have to have a positive and a negative sign down here. I also know that the 2x squared can only be broken up into a 2x and an x. So now that I have a portion of this binomial filled in, I start playing around with the factors of 20 that, when I combine it with what I've already got, are going to subtract to give me 3. So I check my outer, which is a negative 8, and my inner, which is a positive 5, and it does give me back the negative 3 that I need. So again, I just played around with the factors of 20, plugging them into the second slot to find out what combinations were going to give me this piece right here. So I would be happy to see a polynomial in its factored form that looks like this. You can see we have the 4 roots, and we could go on from there. MyMathLab, however, wants you to give the function back where the x term in each of these factors only has a coefficient of 1. And it's this little factor here, it's this group right here, which is kind of giving me a problem, because this x has a coefficient of 2 on it. So in order to get the x to have a coefficient of 1, I would factor a 2 out. Now another way to say that is to say that I'm going to divide both of these terms in here by 2, because if I factor a 2 from the first term in this set of parentheses, I also have to do it to the second term to not technically change what we started with. So I showed this as division down here just so that you would understand what I'm doing, but when I factor something out, I am doing division. So I'm going to divide both of these terms in here by the 2 that I need to get rid of. And I move it down here to the outside. And what it leaves me then is when I divide both of those terms by 2, it leaves me with an x plus 5/2 as the factored form of this binomial up here. So technically, what MyMathLab, oops, I got rid of all of those, but what MyMathLab is asking you to give or provide for a solution in its factored form is this portion right here. Notice that all of the x's in those groups of parentheses have a coefficient of 1. And just so that you know that in this form right here, it does kind of support what we do when we solve each one of these factors, right? Because we are used to stopping right here, setting each one of these sets of parentheses equal to 0, like I did down here, and solving to find the 4 roots that we saw in the beginning. If I had stopped right here at 2x plus 5, when I set that equal to 0 and solve, you can see that x would be equal to a negative 5/2. Well, if I write that binomial by making x have a coefficient of 1, it gives me the same root of 5/2 that we would have eventually solved for down here. So again, this form that I have highlighted right here is the completely fully factored form that my math lab is going to ask you for. Again, I probably would have just been happy with this one up here, but that's kind of how we make sure that it is completely factored.